Hello viewers, in this video I will guide you how to draw the SFD and BMD diagram by using the equation method for this type of loading. The graphical method for drawing the SFD and BMD diagram is the simple method, easy one, but sometimes you need the equation method. It is necessary for you to learn this method. In case of complex loading, complex UVLs, I will tell you further in this video where you can need this, which are the situations where you will need the equation method. These are my reactions that I have find out here. This is VE and this is VA. You can see my another video for reaction. I have explained it in detail. For SFD and BMD diagram by equation method, we will make the equation for this region and for this region and take this distance as x and for this region. So we will make the different equations for these three regions because the loading is changing in these three regions, and in wherever the loading is changing, you will make the separate equation for that region and solve it furthermore. And first of all, I will make the equation for this region, cut it from here and take this distance is x. And this is V1 shearing force acting at this face which we have cut. And this is moment acting at this face. Shear force equation. Sum of all vertical forces equal to 0 and the force acting upward taken as positive and acting downward taken as negative. V1 is acting downwards, so taken as negative. 2 into x is the UDL force acting downward taken as negative, and VA is 11.67 acting upward taken as positive. So their sum is equal to 0. As I have said earlier, the summation of all vertical forces equal to 0. The V1, arranging this equation, I will get this equation. This is my final shear force equation for this region. If I take x is equal to 0, mean at that point I will get the V value, which is 11.67 is equal to VA. Okay. This is my V1 value, and if I put x is equal to 5 at that point, x is equal to 5 at B, I will get V2 is 1.67. And in this region, this is the SFD drawn in this region. This equation can be used for only this region. If I want to find out the shear force value at any point, at here 1 feet, from here 2 feet or 3 feet, I will put simply that value, that distant value here in place of x and find this shear force at that desired point. So this is the use of equation. This can be used only for this region. And now I will draw the equation for bending moment equation. For this I will take the moment about point P1 and take counterclockwise moment as a positive. Taken M1 as a positive because it is counterclockwise. Taken 2 into x is the UDL force value, and x by 2 is its moment arm about point P1. And 11.67 into x is the moment value acting. This create the clockwise moment. This 11.67 create the clockwise moment about point P1. So taken as it as a negative. So is equal to 0 because the summation of all the moments equal to 0. These three moments acting in this case. If I take moment about this point, this M1 acting counterclockwise, 2 into x force create counterclockwise moment about P1, and 11.67 force create clockwise moment. This create clockwise moment about P1. Arranging this equation, I will get this equation. So this is now my moment equation for this region, and in this region I put any value of x from 0 to 5. I will get the moment value for at that point. In this equation, putting x is equal to 0, I will get m1 0, and in this equation putting x is equal to 5, here at B point I will get m2 value 33.5. Drawn this curve like that. So this equation can be used only for this region. Now how this curve is drawn, I will explain you it now. This is my for this region SFD drawn and BMD drawn. Now how these lines are drawn, how this curve is drawn, this I will explain you now. The slope of SFD line is actually the loading behavior, is depend upon the loading behavior, and the slope of BMD line, this is the slope of BMD line, is depend upon SFD behavior. Now see how the loading behavior is. The load here, the UDL load for this region is constant and downward. So slope of SFD line will be constant and negative. It is equal to this value. It is constant, and due to downward loading value it is taken as negative. So the slope of SFD line will be constant and negative. Its slope is constant. It is constant slope line, and it is downward. From this point it is downward, so taken as negative. So this is how the slope of SFD line should be taken. Now I will explain you the slope of BMD line. Slope of BMD line is equal to the SFD behavior. How the SFD behavior is? SFD is decreasing and positive. We move from here to this point, the SFD is decreasing. Here the SFD value is 11 and here it is 1.67. So it is decreasing as we move here. From left to right it is decreasing, and it is positive because it is above the baseline. So the slope of the BMD line will be equal to SFD, which is equal to decreasing and positive. So this slope will be decreasing and positive. How it is decreasing and positive, I will explain you now. These are the some four possible curves that you will draw in BMD, that you will face in drawing the BMD line. Here I have drawn decreasing and positive line. How I get these terms? I get these terms from this SFD value. Now this is the decreasing and positive line which I have drawn here. So this is the positive and decreasing and positive line because it is up above this my baseline, so it is positive and it is decreasing. Here you can see the slope is higher, the slope is low, the slope is 0. So the slope is decreasing as we are moving from left to right. From left to right the slope is decreasing and it is above the baseline, so it is positive. Here it is also, in this case, also above the baseline it is positive. Here it is below the baseline it is negative, below the baseline it is negative. So now the positive and negative scene is clear, and now I will explain you decreasing and increasing. Here the slope is also decreasing because here the slope is, as we moving from left to right, the slope is higher, lower, and it is 0 now. And in this case the slope is increasing. Here the slope is 0, the slope is increased, and the slope is increased as we move from left to right. Also in this case the slope is increasing. So these type of curves you will face while drawing the SFD and BMD diagram. And remember one thing more, the slope of SFD line will be 1 degree higher than the slope of loading acting over here, and the slope of BMD line will be 1 degree higher than the slope of SFD line. Here the slope of the loading is 0, it is constant straight line, it is 0, and its slope is 1 degree line, first degree slope constant, and it is second degree line, so this is how the BMD and SFD should be drawn properly. And these are the few examples that you can see here. This is the 0 degree line. Here the no loading acting, no UDL UVL acting, so here the SFD, their SFD will be 0 degree line and their BMD will be first degree line. And in this case you can also see the load is acting over here, so it is the 0 degree line. Slope of loading line is 0 degree, and here its slope is first degree, and here its slope is second degree. You practice it furthermore. Now let's proceed to our beam. This is my shear force equation and this is my bending equation for this region. Now I will proceed for this region. I will cut it from here, take this distance as a x and make the equation for this region, for this 5 feet span. Similarly the shear force and moment act at this face which we have cut it, and this distance is taken as x. Shear force equation, similarly the positive force, downward force taken as negative and upward force taken as positive, and the summation of vertical force is equal to 0. V2, this one force is acting. V2 is this one. 2 into 5 is this UDL force acting downward, and 11.67 is the reaction acting upward. And arranging this equation I will get V2 is equal to 1.67. In this region the shear force value is same, constant, which is equal to 1.67. It does not depend upon x value as it was in previous case. This equation exists for this region. Now I will draw the equation for bending moment for this region. I will cut it from here, and this is my bending moment acting over here, taken it as a counterclockwise always for the first position, taking moment about point P2. This is my point P2 and taken counterclockwise moment as a positive. M2 is acting counterclockwise, taken as positive. This 2 into 5 is the UDL force, and 2.5 plus x. This is the half of this 5 plus x. This is the moment arm about point P2 for this UDL. So taken as positive because this also create counterclockwise moment about point P. And 11.67 is the reaction. This create clockwise moment. So taken as negative, and into 5 plus x is the moment arm. 5 is this distance and x is this distance. This is the total moment arm of 11.67 reaction about point P2. Arranging this equation, I will get this final equation for this region for the moment. And if I put x is equal to 0 at this B point, I will get the moment at B point, which is 33.35. And if I put x is equal to 5, I will get the moment value at point C here, which is 41.7. This is BMD for this region, and this equation exists only for this. This is BMD for this region, and this equation exists only for this. Really cut it from here and make the equation for V3 for this region and draw the SFD diagram as I have drawn previously. And now for this region I will make the equation for moment. Similarly taken moment about P3, but now this is my M3, create the counterclockwise moment taken as positive, and this is my 10x. This 10 is the concentric load and x is the moment arm, create counterclockwise moment about point P3. We are taking moment about point P3, and this is the UDL value force, and this is the moment arm. Half of this 5 plus x is the moment arm, and this is the reaction. 11.67 multiplied by 5 plus x is the moment arm, taken as negative because this create the clockwise moment about point P1. And arranging this equation I will get this equation for moment for this region. Putting x is equal to 0 in this equation, I will get moment value at point C, because x start from here. X0 value is at point C, I will get this moment value, and putting x is equal to 5, I will get m3 is equal to 0 at this point. The m should be 0 at pin and roller. This is how the BMD can be drawn by using this equation for this region. So these are the few examples for your practice. This is the UDL case and this is its equation. For this UDL case, no loading is changing for this 20 feet span, so we will have one equation for shear force and one equation for moment for the whole span, and using this equation you can draw this SFD, and using this equation you can draw this BMD. And this is my UVL case. For this UVL case, you will cut it from here and have this equation, and you will cut it from here and have this equation for moment, this equation for shear force, and you can practice it in your own work, in your own time. And for any query and any question, you can contact with me. My email is given in description, and you can also comment here. I will be happy to reply you. Thanks for watching.